Good morning, everyone. Myself, Ritika Chetipalli from CSC Branch Section D. Today, I am going to present a PPT on topic called Homogeneous Descriptor System and Homogeneity Based Finite Control of Linear Descriptor System of course matrices and calculus. Homogeneous descriptor system and finite time control. This presentation explores the indicator of homogeneous descriptor system and their applications in finite time control. We will develop into theoretical foundations, practical implications, and case studies that highlight the effectiveness of these systems in real world scenario. Understanding homogeneous descriptor system. Definitions. Homogeneous descriptor system are of class of systems characteristics by their linearity, presence of descriptor variables. These systems are essential in control theory for modeling complex dynamic systems. Mathematical representation. Typically represented in the form of differential equations, homogeneous descriptors can be expressed as E of x dash plus A of x is equals to 0, where E is the descriptor matrix and A is the system matrix. Applications. These systems find applications in various fields, including robotics, aerospace, and automotive engineering, where precise control is crucial for performance and safety. Fine time control overview. Concept. Fine time control overview refers to the ability to drive a system to a desired state within a finite time frame. This is particularly important in applications requiring rapid response. Key features of finite time. Key features. Control include robustness of disturbance, guaranteed convergence, and ability to handle non-linearity, making it suitable for complex systems. Comparison with the asymptotic control. Unlike asymptotic control, which focus on long-term behavior, finite time control emphasizes achieving desired states quickly, which is critical in time-sensitive applications. Real-world example. Applications in robotic arms that must reach specific positions quickly and automotive systems that requires rapid adjustments for safety and performance. Homogeneity-based control technique. Homogeneous control laws. Homogeneous control laws are designed to explore the structure of homogeneous descriptive systems, ensuring that control actions are proportional to the system states. Design methodologies. Various methodologies exist for designing homogeneous controls, including based approaches or sliding mode control with enhances system stability and performance. Stability analysis. Stability analysis is crucial in the design of homogeneous controls, often employing Lenovo functions to ensure that system remains stable under control actions. Case studies. Case studies demonstrate the effectiveness of these techniques in real-world applications, showcasing improvement in system performance and reliability. Performance matrices of finite time control. Response time, overshoot, setting time, control effects are shown in this graph. Case study. Robotic arm control. System overview. A robotic arm control was designed to perform precise movements in a manufacturing environment. The control system utilized homogeneous descriptive techniques and to ensure rapid and accurate positioning. Control strategy. The control strategy implemented finite time control laws, allowing the robotic arm to reach its target position with a specified time frame. Enhance productivity. Results. Post-implementation results showed a 30% reduction in response time and a significant decrease in overshoot, demonstrating the effectiveness of the homogeneous control approach. Implementation. This case study highlights the particular benefits of homogeneous descriptor system in industrial applications, paving the way for the future advancements in automatic technologies. Challenges in implementation. Complexity in design. Designing controls for homogeneous descriptor systems can be complex due to the need for precise mathematical modeling and stability analysis. Complementation demands. Finite time control strategies often require significant computational resources, which can be barrier in real-time applications. Robustness issues. Ensuring robustness against disturbance and uncertainties in system parameters is a critical challenge that must be addressed during the design phase. Visualizing control strategies. Control flow diagram. A diagram illustrating the flow of control signals in a homogeneous descriptor system, highlighting key components and interactions. Stability regions. A graphical representation of stability regions for various control strategies, showcasing the effectiveness of homogeneous control laws. Responsive curves. Graphs depicting the responsive curves of system under different control strategies emphasizes the advantages of time control, finite time control. Future director, future directions in research. Advanced control techniques. Research is focusing on developing advanced control techniques that that levelize machine learning and artificial intelligence to enhance the performance of homogeneous description. Real-time applications. Exploring real-time applications of finite time control in autonomous systems such as drones and self-driving cars is a promising area for future research. Interdisciplinary approaches. Combining insights from various fields, including robotics, control theory, and computer science, can lead to innovative solutions for complex control problems. Sustainability consideration. Future research will also focus on developing control strategy that promotes sustainability and energy efficiency in various applications. Next, advantages. These approaches does not require converting the descriptor systems to its ODE form, avoiding potential computational errors from coordinate transformations or block decomposition. The design and parameter tuning are presented in the form of linear matrix, equations, and inequality LMIS, which make the control easier to use in practice. Performance. The method is shown to be effectiveness in stimulation, leading to accelerated conversion for the closed loop systems. Homogeneous description. The homogeneity property can be verified algebraically and necessarily and sufficient conditions for a linear descriptor system to be homogeneous of a non-zero degree have been developed. This property implies that if you scale the initial conditions, the resulting trajectories will scale by a corresponding amount. Homogeneity in linear descriptor system is a property that, like in standard ODS, implies that scaling the initial condition scales that trajectories. Research has, research has focused on establishing algebraic criteria to verify this property for descriptor systems. Building on this research have developed finite time control strategies for these systems, creating controllers that combine a homogeneous linear feedback term with a non-homogeneous stabilizing term to achieve faster convergence to the origin, often with a design processor simplified by linear matrix inequalities LMIS. Homogeneity-based finite time control. A finite time stabilizing feedback controller is designed for linear descriptor system. Controller structure. The purposed controller consisting of two parts. A linear feedback term that homogenizes the system, a nonlinear homogeneous system that drives the system to the origin in finite terms. There are many advantages on using the homogeneous descriptor system. Homogeneous descriptor system and homogeneous based finite time control of a linear descriptor system. The homogeneous property can be verified algebraically and as a for system described by ordinary differential equations only. It implies scalability of solutions. A finite time stabilization feedback control is designed for linear descriptor system. The purposed control contains a homogeneous linear feedback term and non-linear homogeneous stabilizing term. The parameter stunning is presented in the form of linear matrix, equations, and inequalities. Performance of approach is illustrated by the numerical examples. The homogeneity property is widely used in automatic control theory for system analysis, control and observes designs. Some of the useful features of homogeneous systems are scalability of trajectories, local properties of homogeneous systems can be translated into global ones. The convergence rate of homogeneous systems can be assessed by homogeneity degree. Robustness with respect to external perturbations and measurement noises. Key takeaways. Homogeneous descriptor system and finite time control represent a significant advance in control theory, offering robust solutions for a complex dynamic systems. The integrations of these concepts into practical applications demonstrate their effectiveness in enhancing performance and reliability. Future research will continue to explore innovative techniques and applications, ensuring that the system remains at the forefront of control technologies. Thank you. Hey, Makesh.